All right, can everybody hear me? Great. My name is Ben Silverman. I'm here to talk to you about OpenStack architecture and in relation to AWS product offerings. So before I get started, I'd like to hear a little bit about who I've got in the audience. How many of you would consider yourself AWS architects primarily? Wow, a whole two. Okay, how many people in here are OpenStack architects? All right. Okay. Oh, yeah. Great. I have another name for you, but so how many you guys are? How many of you are have certifications in OpenStack? Any of you? Anyone? Okay. Great. All right. So this is going to be a beginner lecture. So those who are certified, this is going to be a pretty good review for you. For those of you who didn't raise your hands, I'm going to assume that you're either platform agnostic, developers, or just simply confused, or maybe at the wrong conference. The hairdresser conference is next door. So just a little bit, now that I know a little bit about you guys, this is me. It's my big head and my big beard when I had the bigger beard. And then a whole bunch of words about me. These are some of the books I wrote, some of the stuff I did, and I'm assuming you can read, so I'll give you a second. All right, now that we know each other, so this presentation will quickly try to cover some of the common ground between AWS and OpenStack and enable those of you who are familiar with AWS. I'm hoping some of you are at least familiar with AWS to come up to speed with OpenStack cloud services. So, if those of you, I think there was only two AWS architects out here. So, AWS is a division of Amazon. It's self-described as a set of products that were designed to provide a broad set of infrastructure tools and services such as computing power, storage options, networking, and databases delivered as a utility with, here's the important part, pay-as-you-go pricing. The OpenStack project, on the other hand, describes itself as a cloud operating system that controls large pools of compute, storage, and networking resources throughout a data center, all managed through a dashboard that gives administrators control while empowering their users to provision resources through a web interface. That's a lot. So the important difference here is not the technical bits, really, at this stage. It's the business wording. Amazon is a set of products designed to provide infrastructure services delivered as a utility. Again, there is the pay-as-you-go pricing. OpenStack, on the other hand, is a cloud operating system that is designed to control many types of existing resources through the data center and empowering users to have self-service and provision their own resources through a dashboard. So let me break it down even further for you. AWS provides services for money based on how much and how many you use. OpenStack itself makes no money. Vendors make money on services and support, but from the project, and certainly not based on usage and product selection. So the point here is AWS creates products that are easy to use, very simple to use, using the least expensive hardware they can find or create themselves, and still deliver, obviously, adequate performance, and create as many products as they think that will be viable to sell to customers. So if they have a lot of products, each time you turn them on, you pay money. So it's a totally kind of different model. So when we're talking about the comparison between OpenStack projects or services and Amazon products, you'll see that Amazon, if you look at Amazon, you'll see that they have about 1,000 distinct different products. That was not by accident. They didn't have a community of 40,000 people putting these together because they thought that the community needed them. They had a room full of people saying, how can we monetize something? I have an idea, let's do this. Will it make us money? Yes, program it. So again, that's the biggest difference. I don't believe they even thought about like how many people are going to use this. I guess they figured if enough people used it to pay off the developers that we paid to make it, then great, it's a success. So However, like Amir Sharif wrote in the New Stack days after the reInvent event, which is AWS's yearly event, Amazon Web Services is a scary beast. It's a fast-moving, hungry hippo that devours everything in its sight. And it's Hotel California. You can check out anytime, but you'll never leave. That's why today we'll talk about components that bridge platforms, not services that are proprietary to AWS. OpenStack is simply a free and open source project that uses open principles to develop features and new services based on the need and feedback from users. Projects are staffed by community developers and volunteers to support these projects. So before we get to the nitty-gritty, I want to point out a few things. I really like public cloud. Don't get me wrong. I like AWS. I know it sounds like I'm being hard on them, and I'm being hard on the public cloud space in general, but I'm not. I think it has value in many different architectures. I'm also a fan of Google Cloud and of Azure. When considering what I'm talking about up here, when you're considering feature parity between OpenStack and AWS, I want you to think about, if I say, well, AWS does this, AWS has that, think about, do people really need this feature? And how many really need it? If I say, there's a product called Kinesis, and it does streaming data, and it's just great for this one tiny use case, think about how many people actually are using that. And then think about the OpenStack model, trying to deliver a set of services to the largest amount of people that find the most use. Whereas, again, we talked about the AWS, Google, Azure model. And I really want to make it clear that OpenStack is not competing with AWS. It never was. That was what pundits really had fun with since AWS came up. It was, well, they're losing to AWS. They're losing to AWS. Or they're gaining ground on AWS. No, they're losing. No, it was never a competition. It actually reminds me of my two sons. I tell them it's time to go to bed, and they want to play some more. So they want to go upstairs, and one wants to play on his computer, the other one wants to go play the PS4. But it never fails. If they both get to the stairs at the same time, it's almost like a boxer's bell rings, and they both run up the stairs at the same time, elbowing each other in the face, tripping each other, while the whole time yelling, "It's not a competition. It's not a competition." So, and I always say to them, stop fighting. It's not a competition. Just get upstairs. I just want to make that clear that OpenStack is not competing with AWS. They have different use cases, private and public cloud. They both cater to programmable infrastructure, but they have definitely different architectures and different uses. So I always find it most useful for when I'm demonstrating something or when I'm trying to explain something to use real-world examples. So to start the architecture discussion, we're gonna start very simple, and I want to use an application that I feel a lot of people or an architecture that a lot of people I think are very familiar with, and it's a basic 3-tier web application with a DNS component. You like that? It's kind of like 3D and sideways. If there were a lot of AWS architects in here, they'd be like, "Hey, I recognize that. This is really an application that's kind of a web-enabled application, kind of like Lucid Chart, but it has a lot of built-in AWS icon functionality. So a lot of AWS architects use it to draw. But as you can see, this is a standard architectural diagram for a 3-tier basic HA application. Simple layout with web, app, database. And uses object storage for the static web content. Networking is fairly simple and straightforward, and compute and storage are standard fare. I didn't break it down that much. I didn't say, well, it has to be SSDs or has to have so many IOPS. It's just we're keeping it very simple here. Now this is what it would look like if it were in AWS. And as you can see, it's got products listed now. It's got different instance types, M4s. It's got Elastic Load Balancer in the middle, using RDS for the database, still, again, using S3, and using Amazon's patented Route 53 DNS with auto-scaling being provided by their built-in functionality. So Again, I don't know how many people are out here that are AWS savvy, but this would be fairly familiar to you. And if you're not AWS savvy, you can actually use this whole lecture. You can play it in reverse, and it'll teach you about AWS from an OpenStack standpoint. Now we moved it to OpenStack. Do you see how different it was? It shifted. Like, it was so crazy. I had to move a whole bunch of stuff around, change everything. No, pretty much I just changed the logos. It's exactly the same. So, in a basic sense, there's no tectonic shift here. The architecture remains very simple, very similar, with some difference. Names change, of course. At the detailed service level, there are some definite differences in the details of the individual services. But, let's take a look at each one of the services that I have here in the diagram and talk about them in relation to AWS services. So, as you see up at the top, Nova Compute is like Amazon EC2. I was going to make that logo, like, have you ever seen in the supermarket or in the perfume aisle? It says, like, if you like Obsession, you'll like 3 Horses or something like that. Like, they completely changed the name, but it smells kind of like the original one, but like generic, like they put like a banana peel in it or something. It like really stinks, but that's just kind of the same way. If you like Nova Compute, you're going to like Amazon EC2. If you know what Amazon EC2 is, you really kind of know what Nova Compute is. So it's, Nova is the compute orchestration engine. Provisions, configures, and deploys instances. But like EC2, it also requires other products and services to complete a full compute deployment with things like block storage and networking. So later, when we talk about the workflow in provisioning a new instance into the AWS console, we'll see these similarities also in Horizon. Cinder block storage. Again, if you like Cinder block storage, you're going to love Amazon EBS, and that's Amazon's block storage, enhanced block storage. So when you go into Amazon and you configure an instance, it asks you, just like in OpenStack Horizon, what kind of storage do you want? What kind of block storage do you want? You may have different storage types. You may have a NetApp FAS. You may have a EMC VNX. You may have local storage. In Amazon, they ask you similar questions, but with a slight difference. Slight difference is they have a provisioned IOPS option inside of Amazon. So let's say you need 3,000 IOPS. You can specify that. OpenStack does not have that. What they do have is the opposite. They allow you, through flavors, to QoS the amount of IOPS each instance has. And so it's that paradigm. You say, well, why would OpenStack allow you to restrict the IOPS but not allow you to provision a certain amount of IOPS? And why would it be advantageous for Amazon to allow you to put any ridiculous number of IOPS that you need? Do you think maybe they think the developers that are going on there, they don't really know how many IOPS they need? And they say, well, I need 99,000 IOPS. What's the net result of that? So I use 99 IOPS. I use 10 IOPS. I'm a web server that gets hit like once a week, right? So I use 10 IOPS, but I put 99,000 IOPS down. Yeah, you're going to be charged for that type of volume. You're going to be charged for that type of storage over and over and over until your corporate card gets taken away. So again, if we look at some of the features that Amazon offers, yes, it's great to be able to specify how many IOPS that you want, but again, there are cautionary tales that you have to adhere to. From the network perspective, we have Neutron. If you like Neutron, you like AWS VPCs. And again, it's not a 100% parity. It's not one-for-one parity. VPC does have a lot of network tools built into it, really at the detail level. But for the most part, it really does. From a network perspective, OpenStack provides control over layer 2. Those elements in the virtual network. AWS only exposes subnets. So you're only working at layer 3. OpenStack Neutron's API allows granular control over elements such as ports. You really can't do that with AWS. You're abstracted farther away from the hardware. I mean, they don't want you near the hardware. They don't want you touching the hardware. They don't even want you knowing what the hardware is. Does anyone here know what brand of servers AWS runs on for T1 instances? Anyone? With any sort of certainty, not making things up. Like, it's a Dell 301. It was never offered to the public, and it was a FBI CIA joint operation. No conspiracy theories. I'll tell you, the last I checked, last I was able to find out, they made them themselves, like Google, and they have shaved down the motherboards to only provide the functionality that the base server needs. They've got 4 power supplies in the back with ribbon cables, and they go halfway through the chassis unobstructed because there's nothing in the back of the chassis. Hyper undense. They just have in there what they need, and that's it. It keeps cooling down, keeps power down, and just the I/O they need on there. So, do they want you messing with that? Do they want you, NUMA pinning to their weirdo CPU configurations? No, they don't. They want you to consume what they have, and if you don't like that, there's a C instance, and then there's an M, and there's an X, and then there's GPUs, and they all come at a very generous price. And the more you use, the happier you'll be. And I don't own AWS stock, so. In the private cloud, user manages the physical networking by themselves. Thus, it's crucial for virtual networking to be integrated with the physical layer. However, public cloud is managed as a managed service that takes all the hassle out of you picking network cards, smart NICs, NICs that support SRIOV. Amazon will take care of that for you. So, therefore, you provide all of the L2 services to Amazon, and they provide none to you. So, as for layer 3, the networking is pretty much conceptually the same. They provide comparable capabilities. Both cloud services allow the creation of virtual network subnets, but OpenStack allows the use of several subnets on the same virtual network, which is explicitly prohibited into a VPC environment. Both clouds provide routing services. You can bring up a router in both environments, but in each VPC environment, it includes an implicit virtual router, and the API allows the user to set a routing table. Whereas in OpenStack, as some of you may know, that it seems like a lot of you are very OpenStack savvy, you can bring up your own routers. You can modify the routers, you can modify the routing behavior, and you can place the routers in certain areas. You can have a distributed router, or you can have a centralized router. No such option exists in AWS because, once again, you're playing with their virtual and physical architecture, which is not going to be allowed. From a network security perspective, AWS and OpenStack pretty much offer the same thing. Same mechanisms. Security groups are used to control inbound and inspect traffic at the instance level. Glance is very simply just AMIs, Amazon AMIs. So, does anyone not know what an AMI is? It stands for Amazon Machine Image, and it's just a QCOW2, pretty much. The structure of it's a little different, but it is just a compressed instance type, image type that you put into the system and then provision onto a VM. Not a lot to talk about here. Just if you like Glance, then you'll love AMIs. Swift. This is the most compelling one that's very interesting because Swift has been and continues to be fully S3 compliant. So that's very important for this particular project in OpenStack, is that it maintains its parity with the AWS S3 feature set. So if any project is tightly coupled with AWS, this one will be the most tightly coupled. Keystone provides identity, authentication, and authorization, key pairs, and network security through ingress and egress rules. And they both provide capabilities of virtual firewalls. It's there is a joke that a lot of people don't understand the IAM inside of AWS, and I'm going to have to agree. I've taken the exam, and I would have to say that that was one of the hardest things, is to learn how to secure AWS, how to delegate roles and sub-delegate roles, to go in there to set up security on S3 buckets, making sure that all the buckets are taken care of. Are my buckets encrypted, not encrypted? So when you hear that, there was a scan of AWS and there were like 19,000 credit card numbers or 19 million credit card numbers exposed in S3 buckets, that's why. It's not because the people didn't know how to use S3, they didn't know how to use IAM. I find Keystone with the AD connectors and LDAP connectors much easier to use. Again, I'm not here to bash AWS. I'm just here to kind of point out the differences between the two. All clouds are special. Designate. So designate is Route 53. So if you've ever gone in, you've ever put a domain into AWS, you were given a nice GUI with a kind of a form-based chart that you can put all of your nice A records in and your MX records. It's gorgeous. It's really a nice tool. Unfortunately, OpenStack has a designate dashboard, but it's not quite as robust as AWS's. However, functionally, if you set up bind or power DNS or info blocks, functionally it does the same thing. It really DNS is pretty much DNS. I mean, who are we kidding? Sorry, Infoblocks guys, whatever, Power DNS guys, but DNS is DNS. You have records, and they do translations from IPs to names. And in both instances, they hook into Neutron or into the network, and when instances are provisioned, it'll give them names, internal names, if you so want, or external names. So good functionality needed for a lot of the web architectures. Trove, or OpenStack Database as a Service. Now this particular service actually extends across multiple, and I don't even have them all listed at the top there, multiple services in AWS. And these are all of their, well, not all of them, but just a sampling of some of the database offerings that they have. If you like RDS, you're going to love Trove. Trove is Database as a Service for OpenStack, and it's multi-tenant and integrates with Nova, Glance, Cinder, and Swift for database configurations. And what it does is it provisions databases. So instead of running your Cassandra on your Azure or running it on AWS, Trove will do the same thing for you. It will provision it out. It will help you with your configurations, help you with your updates, even help you with HA and clustering. Again, very similar to AWS. One of the things that AWS has differently, though, is they have a few of these databases, like DynamoDB, that they wrote. Aurora, they created those. And remember when I talked about being a roach motel, and you can check out, but you can never leave? That's one of the checkout, but you never leave, right? So if you're using a proprietary service that Amazon wrote, and I don't really care how fast it is, but if it's got a structure that you can't use anywhere else, if you decide to move your workload to Azure, move it back to OpenStack, move it to bare metal, move it to containers, if you're using DynamoDB, you're not going to do that. DynamoDB is not portable. So this is just a cautionary tale for those who are thinking about hybridizing their workloads or doing multi-cloud. Just keep an eye on what services from Amazon you're using. One of the things I did want to do is get a screenshot of all the services. I didn't get that, but they would be, if I had a screenshot here of all the services in Amazon, they'd be about as big as the S on the is like, and they would fill up the whole screen. That's how many they have. So when I said earlier, like, look at them and figure out which ones you want to use. I've got a 3-tier web architecture here, probably one of the most common architectures that you'll find in any enterprise. They don't use any proprietary services, none of them. It's just when developers see the little shiny object and they think, ooh, I'm I'm not going to put that on a server. I'm just going to go get that service. That's when you start getting into trouble. That's when you start signing up for services that are proprietary and you can't move them. They can become unportable. So for you architects, just make sure you know what you're getting into if you're getting in and know how to get out. Have an escape route. I know it's like 007. So this is, if you guys are familiar with OpenStack, as most of you said you were, you'll recognize this screen, right? This is the opening credits. And this is where we provision instances. So I was expecting a lot more AWS people, so you'll have to imagine an AWS instance provisioning screen, because I was assuming everyone here knew what that looked like. So the first screen that you get from AWS is you choose an AMI. So if you can imagine a screen like this with words and then a whole bunch of glance images, names down there. That's choose an AMI. So you pick an image, and in OpenStack that's located under the source tab. Just like in AWS, these images could be public images or they could be ones that were bequeathed to you by your administrator. Next, you choose an instance type. Remember when I talked about the C4s, the T1s? They all have meanings. Some are compute optimized, some are memory optimized, some are GPU, some are graphics optimized for doing VDI. Not graphics as in GPU, but as in graphics. Some of them have FPGAs in them now. So there's a whole ton of different types, if you will, flavors. Again, in OpenStack, we call these flavors. Configure instance details. That's the next step you would do in an AWS. That translates over to some of the options that are defined in the details tab. So when you configure the details, you give it an instance name, pick an availability zone, and again, here's a very important point. Anybody here know the difference between an AWS availability zone and an OpenStack availability zone? Sweet. Okay, in AWS, an availability zone is a physical location off of a regional location. So if you have something, a region kind of like Northern Virginia, that's their most popular region, Northern Virginia, availability zones are data center locations in that region. So they're just different locations in the region. Availability zones in OpenStack, typically how they're used, is for fault tolerance. So you'll put one controller in a rack in one availability zone and with some computes, another controller in another rack with some availability zones, and that's how you separate them. Harder question is, who can tell me the difference between host aggregates and availability zones? All right, I won't get into that argument. You guys can look that one up later. That's a very famous argument of how those are used. So with this, so they have this has the availability zone of Nova. That's the default availability zone here. A lot of people will choose rack names for their availability zones, like rack 1, rack 2, rack 3. And then how many instances you want to provision. Also the same on the AWS console. In the AWS console, there is options like enable detailed monitoring, and whether to use a shared or dedicated hardware resource. They are not; those options are not here explicitly. Detailed monitoring is provided pretty much by default, and is configured obviously in Ceilometer or Manasca or whatever you're using for your metering. It's not an option here. Can anybody guess why they have a button for enable enhanced monitoring on the AWS site? Money. Enhanced monitoring costs more money. So they put it out front and center, just like in stores. All the brand name stuff is right at eye level. And another one for them is the dedicated hardware instance. So if you want your own server in Amazon, you can have it, right? But you're going to pay and pay and pay and pay. So here, you can have your own, but again, you can create it by using host aggregates and flavors and anti-affinity rules. There's a bunch of ways you can have your own server. But it's not a button that you can push very easily because it's really not something that a lot of people willingly push or on purpose. The next tab is add storage. We talked about adding storage, right? So adding storage is the same. It's under the source tab as well here. And when we talk about storage, we talk about what the initial volume size is going to be, and you pick a storage type. Pretty simple. No IOPS question, no provisioned IOPS, no crazy questions there. And as I said, you can have multiple storage types just like AWS offers: SSD, spinner, solid fire, Ceph, Scale IO. Did I leave anybody out? Am I pissing anyone off? Anybody remember? Okay, all right. So, add tags. Now this is something that came along a little bit later in OpenStack, but if you see the metadata tag here, a tab down here at the very bottom, this allows you to do the same thing as you do in AWS. It's add key value pairs to your instances. So in AWS, a typical thing that you do when you create an instance, you do a tag that says name and then equals the name of the instance. Location equals, Seattle. Previously, in earlier versions, you couldn't do that. You couldn't put a key value pair and attach it to your instance, but now you can using the metadata tab. So when you're finished with that, when you're finished adding tags on AWS, you just hit go, and it's happy times. It takes a few seconds and it provisions it. When you get done with metadata here, you push go, and it's happy times, and it gives you a server. Comes out pretty much the same. Now they'll say, well, Ben, how can it be the same? It's not really the same. Yes, it's pretty much the same. Amazon uses some sort of weirdo Zen hypervisor. Most people that today are running OpenStack are using KVM. That might be a difference if you're not using Zen, but for the most part, it's putting an image on a virtual machine with a whole bunch of specs, connecting it to networks, and pushing it out. So, I know a lot of you are not AWS architects, but going through it, we can see that I didn't have to go into long details about how to create the same architecture in OpenStack. So as you can tell, there's a lot of similarities in AWS or EC2 instances. And because the services are very similar, there's even an EC2 API that is inside of OpenStack that will allow you to provision instances onto EC2. Now this was voted a little while ago after some heated discussion whether to remove it as default from Nova, and they decided that it's a external project that continued on and that has to be added back in to give full VPC functionality to Nova to create full instances into AWS. But all the things that you're specifying in that previous screen, they all get translated over into EC2 parameters. And you'll see here, and this is just a snippet of the available references in the API that translate over. This goes on for a long, long time. So the mission of the EC2 API was to implement VPC API, which is now absent in Nova's EC2 API. To create a standalone service for EC2 API support, which accommodates not only the VPC API, but the rest of the EC2 API functionality currently present in Nova. All right, but that's not all. If you buy now, there are even more projects that align very closely with projects in OpenStack, or at least partially with AWS products. Here's a list of them that will either cause you to go blind, or check your glasses, make sure you have the right prescription. I'm sorry, I really wanted to get as much as I could out of this, and that wasn't so much for live, but when you all send me emails after the summit and say, can I have the deck? This will be in there for you. I'm hoping I can get it attached to the video at the end. And as you can see, I mean, these are maybe over to the right, the OpenStack services. I mean, these may not be projects that you're very familiar with, or maybe you are familiar with them, but maybe on the left you're not familiar with them. But I encourage everyone to go to AWS and play around. If you're familiar with the ones on the right, go ahead and play around with the ones on the left when you get in there. A lot of these are part of AWS's free tier, which means they give you a year's worth of credits, and you can go in and play with any of this stuff. I would read the free tier FAQ to make sure you're not charging yourself money, because it is possible to go beyond the limits, but they're all there. Now I'm sure that there may be some that I've missed or cross. There may be more that are that do the functionality of some of this, but for the most part, that's pretty accurate. So hybrid and multi-cloud with AWS. I'm gonna try some more crowd participation. Can anyone tell me what hybrid cloud is? Wow, man, is that scary in here? How about you, Tim? Haha, you were gonna heckle me. I got you first. Anyone? I know you know. All right, right here. Okay, private and public as one infrastructure. So good. That's good. That's a good start. I do have a question about that though. Is there a workload that spans them, or you're just using some public and some private? That's why it's not really a trap because as you can. Right. Okay. So is there any traffic that's or any workloads that's spread across both your clouds? Or is it just like, does web and app run in Amazon and database runs in OpenStack, or vice versa? I mean, is it you have a 3-tier running there and you have a 3-tier running back in your private cloud? So well, I guess what I'm getting at is it's funny because they ask these folks, hybrid cloud definition, what is it? Use of public and private cloud, okay? And then the other people have different answers. A cloud plus any additional clouds for non-cloud infrastructure. And then, of course, the last one, multiple application portfolios across multiple deployment options, which is also kind of vague. But I would say it's a combination of all three of these. The way NIST defines it, it is any two clouds, public, private, and community, and this is for hybrid, where you have a workload that spans across the clouds. So the workloads have to be connected, or there has to be something about a workload or a business process that depends on both clouds kind of simultaneously. If you take that and you say, well, then what is it when I just have web servers running here, running there, running Google, whatever? That's where we have multi-cloud. So you have a multi-cloud strategy, whereas you are running maybe the same workload in multiple places, but you're not reaching across any of the clouds to provide you with anything. So for example, if you had a web app running on Google Cloud, but you were relying on the DNS on Route 53 in AWS, that would be a hybrid cloud. If you had web and app in an availability zone on AWS that was reaching back into OpenStack for its source of record, for its database, that would be a hybrid cloud. If you had a 3-tier architecture like we talked about here in all 3 places, and they were independent and didn't talk, but maybe they were even offering the same service. Maybe you had a remote load balancer or DNS round robin that would go to these three. It's still multi-cloud. So, and I'm sure people would argue with me, but I welcome the argument. But anyway, so that's really, if you put that in consideration here for what we're talking about with OpenStack and AWS, it lends to either one, because you can have these cross-pollinated applications using similar tools that we went over to today, and be familiar with them. The real bugaboo in the whole multi-cloud and multi-cloud and hybrid cloud is a cloud management platform. It's not so much if you can do it or what you can do, it's how you're going to do it. How are you going to orchestrate it? How are you going to manage it? And how are you going to maintain it? And then we won't even, you can, that's a real rabbit hole you can get down into. But that's important. It's important to understand the features of one, the features of the other, and not going into something that's going to lock you in, that you can't do a multi-cloud, you can't do a hybrid cloud. So don't, again, I pick on Kinesis, I can pick on DynamoDB, I can pick on anything that you can't move to another cloud and it doesn't work the same way. So your deployment is different then for every cloud. Your strategy is different for every cloud, and that really makes a mess of things. So that's really the point with this slide. And now we get to Q&A. So if you'd like to ask questions, please line up at the microphones in the aisle.
Could you go back to the slide that showed the 3-tier architecture for Amazon? If that's not hard.
No, that's not hard at all. If my mouse would work here. Hello. Oh, I went to the end.
Sweet.
There we go.
So I'm not going to let any of my developers use that architecture because it uses EC2. I'd go Lambda, and I wouldn't have a single VM. I realize that locks me in to Amazon architecturally, but I can have them deliver that in 4 hours instead of 4 weeks. And time to market's really important to me. So that I was expecting to see some comparisons to those kind of optimal AWS architectures, not VPC and EC2, because we're not doing that anymore.
Okay. Well, I appreciate you taking the kind of the modern approach to going this function as a service with Lambda, but as you say, it locks you in. So, and that's fine. People have an AWS first posture, and when you have an AWS first posture, then that's great. Then you can go to AWS and you can use all of the AWS features because you're never coming out. I have a problem with that because Forrester and Gartner have published a report, I think it was a year or two ago, that says 39% of applications that were put in the cloud were repatriated. So when you get it in there and now you're using it, you think, I'm going to go AWS first. I go in there and I use all this special functionality. You spent, I don't know how much money with a partner or within your own company to migrate those applications or decompose them into functions as a service. And now you find out it doesn't do what you want, it doesn't scale like you want, or it doesn't perform the same way you thought it would. Now you have to do a double migration. Now you have to recompose those applications and put them back in your data center.
I get that, but I guess we would be part of the 63% that stayed there because it works better for us. For enterprise applications, that is what we are finding.
Sure. And for those people who build their own applications, all those things are available. But when you're talking COTS applications that are even cloud-first applications, Nginx, Tomcat, some of the other things like that, function as a service just doesn't cut it. But as I said, for you, going that direction, it works. Lambda's very popular, so it's working for a lot of people. But there's a lot of people that still want to do EC2. And I would say even more popular than Lambda is obviously, and you guys have probably attended a lot of these lectures nowadays on ECS or EKS, right? Going into the container model. And again, containers are another layer of abstraction, but the point of containers were to kind of level the playing field, right? Because a Docker container or a container here is a container here is a container there. We all know that that's not quite. We haven't reached the dream stage yet, but there that is. So I could have done that with this, but I wanted to make it simple. I expected, as an AWS lecture, more AWS people to show up. I thought they were hiding somewhere in like the crevices, and I'd see them crawl out and come in here, and they'd feel at home, like we'd all give them a hug. But yeah, so any more questions? Any hecklers? Here's your chance. Oh, yes. He's right.
There are open ways to do functions as a service also,
Sure.
I'm not suggesting that you would do so. Thanks, Ben. I'm not how did we end up this? What is this thing? I've known Ben a long time, so we do a great deal of function as a service within our company and build architectures for that. We do work with Lambda also. But we also use OpenWhisk and other tools that are available. We're doing some new exciting things around PHP for, shockingly enough, around event handling and doing function as a service there. So there are modern, I would suggest even that the most modern ways of doing function as service is in the open space and not within AWS. And we're doing, IBM and other companies are doing OpenWhisk on OpenStack. Not sure that makes sense, but that's another story.
Right.
But there's a lot of ways that we really are that edge, and I encourage Amazon to. Let's keep innovation running. But at the same way, the open source edge of function as a service is really where the fun is.
If we can coalesce around a single good open source solution for function as a service, that's where we need to get. The problem we get into is the internal open source competition for innovation. That's a cool thing. But then if every year I have to learn a new technology and I'm constantly evolving, then I'm spending a lot of development time doing that constant evolution.
There are CI/CD methodologies that help take advantage of that process that we work with customers, and I know there's other folks here that probably do also, to help show how that actual curve can accelerate and create efficiency as opposed to stealing off the curve.
Yeah.
And we're not debating.
Yeah, no.
But
I get it.
So I don't want to take away from that either. What you're doing in Lambda is fantastic. That's great. It doesn't. My point is it doesn't take away necessarily from what Ben was saying, because there's a lot of great open source ways and an OpenStack ways to do the same thing.
Right.
Thank you. That's Mike McCain. Yeah, we've done a little. Is there any other questions at all? If not, and you're watching on YouTube, please click the subscribe button down below here. OpenStack Foundation would appreciate it. Thank you very much. Thank you, everyone. Have a good afternoon.